Okay, this is Edexcel GCSE Higher Paper 1 from November 2018. This is a walkthrough. Now, Paper 1 will be a non-calculator paper, and so we'll get cracking. In this paper, there's roughly 22 questions on it. So here's question 1. It says, work out the value of 3 to the power of 7 multiplied by 3 to the power of negative 2, all over 3 cubed. Now you would make a serious mistake if you did 3 times 3 times 3 times 3 times a lot of stuff. We can use index laws on this. We've got 3 to the power of 7 multiplied by 3 to the power of negative 2. Now when you've got the same base number and you're multiplying, you add together the powers. So you're going to get 3 to the power of 7 plus minus 2, which is going to be 3 to the power of 5. Now that is being divided by 3 to the power of 3. When you've got the same base number, you can subtract when you're dividing. So you're going to get 3 to the power of 5, take away 3, which is going to be 3 to the power of 2. Now 3 to the power of 2 is 9, is the actual value of that. So the answer there is 9. It's nice, it's 2 marks to start the paper, nice and easy. Now this question says v squared equals u squared plus 2as, where u, a and s have values given. V squared equals u squared plus 2as. Now v we don't know, but we do know that u is 12 squared plus 2 lots of a, which is negative 3, lots of s, which is 18. I like to write these things in brackets because it gives me a good habit for when I do papers 2 and 3. Putting things in brackets like this in your calculator means that your calculator won't make a mistake with it. V squared equals, well, 12 squared is 144. 2 times 3 is 6. 6 times 18, well 6 times 10 is 60. 6 times 8 is 48. Add those up, you get 108. But there's a negative here. Now, a singular negative gives us a negative result. If there are 2 negatives, you get an even. If there's 3 negatives, you get if there's 2 negatives, you get a positive. If there's 3 negatives, you get a negative. Okay? We've got v squared is equal to 36. If there's just 1 negative, you get a negative result. Now that means that v squared equals 36, and so therefore v, if we square root both sides, is going to equal 6. V equals 6. Okay? V equals 6. That's a value of v. There is another one, which is v equals negative 6, because another square root of 36 is negative 6, because negative 6 times negative 6, 2 negatives make a positive. But at this start of the paper, nice and early, v equals 6. That'll do. Make s the subject of that formula. Now, s currently isn't the subject of this formula. To get something to be the subject, it's got to be by itself, on its own side of an equal sign. Now at the moment, s is being multiplied by 2a, and then we're adding on u squared. Take s, I multiply it by 2a, then I add on u squared, and I get v squared. So the first thing that we're going to do is get rid of that very last layer. The very last layer was to add on u squared. So we're going to take away u squared from both sides. And we're going to end up with v squared minus u squared is equal to, well, u squared take away u squared, that just goes, doesn't it? Okay, and you get 2as. Now s is still being multiplied by 2a. So we're going to divide both sides by 2a. And you get v squared minus u squared all over 2a is equal to s. And there we go. S is equal to v squared minus u squared all over 2a. Alright, there's question 2 done. Moving on. A bonus of £2,100 is shared by 10 people who work for a company. Now 40% of it is shared between 3 managers, but the rest is shared between 7 salesmen. Now one of the salesmen says, if the bonus is shared equally between 10 people, I'll get 25% more money. Now we need to find out if he's correct. Now there are 2 cases here. You've got the case that's actually happening, okay, where you've got 40% to the managers and the remaining 60% to sales. Okay, and you've got the other one where it's all evenly shared. So 60% goes to sales in this case. But what is 60% of 2,100? Well, 10% is equal to 210. If we multiply that by 6, we'll find out that we've got £1,260 is 60%. Now this salesman is just one of 7 salespeople. So he gets 1/7 of this 1,260. Now 7s into 1 don't go, 7s into 12 go once, remainder 5. 7s into 56 go 8 times, and 7s into 0 go 0 times. And so actually he gets £180 through this plan. His plan though, to share it evenly between all 10 people, well, he's going to get £2,100 divided amongst 10 people. He's going to get £210, which is more, but is it 25% more? He gets £30 more. Now, he's saying that he'd get 25% more money than he's currently getting, which is this amount here. Now, 25% of 180, you can halve it and halve it again. 25% of 180, well, half of it is 90, half it again is £45. He gets £30 more. Is that as much as this? No. Gets £30 more. That is not as much as £45. So no. He wouldn't get 25% more money. He'd get more, but he wouldn't get 25% more. Okay, moving on. It would take 120 minutes to fill a swimming pool using water from 5 taps. So there's all this work and it's being divided amongst 5 taps. How many minutes would it take to fill the pool if only 3 of the taps are used? So 120 minutes is 5 taps. What would happen if we only had 1 tap? Surely that would take 5 times longer. Definitely will do. Okay, because you're not sharing it amongst 5 taps. It's going to do 120, 120, 120, 120, and 120. So it's going to be 600 minutes of work in total. If you only had 1 tap, there's 600 minutes to do. Now, if you've got 3 taps, you're going to take 1/3 of the time. It's going to take you 1/3 of the time because you're dividing it amongst 3 taps. So actually, it's going to take 200 minutes. State one assumption that you made. Well, one assumption that I made was that all of the taps work at the same speed. They're not necessarily going to. You might have one tap that's a very, very, very powerful tap and one tap that's very, very weak. And so the assumption that I've made is that all taps work at the same speed. Okay, they might not. Might well be that this has got 4 normal taps and 1 super tap, and then this is 3 just normal taps, and so this would have been quicker. Okay, moving on. A plane travels at 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. Now, an estimate means that we're going to have to do some rounding to one significant figure. Now, 200 would be this rounded to one significant figure. It's 200 miles per hour. But we want to talk about seconds. Not really interested in hours. So we want to convert hours to seconds. Now, 1 hour is equal to 60 minutes. 60 times by 60 is 60 minutes, each with 60 seconds, which is 3,600 seconds. So actually, the plane is travelling 200 miles per 3,600 seconds. Okay? It's the exact same. 1 hour is 3,600 seconds. You can count it if you want. But it's a nicer way to look at it because we're going to be talking about seconds in a minute. All right. Now, I want to know how long is it going to take to do 1 mile. So I'm going to take that journey and I'm going to chop it up into 200 little parts. Now I can do the same over here. And I can find out how many seconds it takes to do 1 mile. Now 3,600 divided by 200, cancel, 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 cancel. 36 divided by 2 is 18. And so 1 mile per 18 seconds. Is your answer an underestimate or an overestimate? Well, let's talk about what I did with this. Okay, I said that the plane was going to be slower than it actually is. But in real life, it's faster. If it's faster, it should take less time to travel the mile. So, in real life, the plane is faster. So, it should take less time to do the mile. So I have too big of a number. It might be 17 point something, which means that I have overestimated. Okay, moving on. Solve the simultaneous equations. Now, to solve these simultaneous equations, we need to get common coefficients. So I need the same number in front of the x's or the same number in front of the y's. At the moment, I don't have that. Now I'm going to leave this equation just as it is, which is 5x plus y equals 21. And I'm going to take this equation, I'm going to multiply it by 5. If I do that, what I'll get is 5x minus 15y equals 45. Now that's really useful because now these things match. Now if you've got the same signs, same sign, subtract. Same sign, subtraction. Okay, you can see that these are the same sign. So we're going to do a subtract. We're going to do the first equation, take away the second equation. Now 5x take away 5x is 0. Y take away minus 15y. So we've got y minus 15y. That'll be y plus 15y, which is going to be 16y. And we've got 21 take away 45. Now 21 take away 45 is negative 24. You could just do 45 take away 21 and put a negative in front. That's what I did. So 16y is equal negative 24. If I divide both sides by 16, I'll get y is equal to negative 24 over 16. Which is y is equal to negative 3 over 2, because these things can cancel down. Okay, 8 goes into each of these, which we could also express as y being equal to negative 1.5, which some people prefer. Now, that there is part of the answer, but we don't know what x is. So, use one of the original equations. I'm going to use the one up here that's got no negatives in it. 5x plus y is equal to 21. Now this y is actually equal to negative 1.5. So we've got 5x plus minus 1.5 is equal to 21. That means 5x minus 1.5 is equal to 21. We can add 1.5 onto each side. And we'll get 5x equals 22.5. And we can divide through by 5 and we'll get x is equal to 22.5 divided by 5. Now 22.5 divided by 5, I happen to know is 4.5. There are a few ways to know this. Now one of them is obviously to just do 22.5 divided by 5. 5s into 2 don't go, 5s into 22 go 4 times, remainder 2, and 5s into 25 go 5 times, you get 4.5. Another nice way to do it is if you've got 22.5 over 5, you could double the numerator and double the denominator. You get 45 over 10, which is 4.5. It's a nice way of doing it. Okay, there's lots of different ways to do that, but there you go. Moving on. Next, the diagram shows a square with a square ABCD with sides of length 20 centimeters. Now that's 20. This is a square, and so this will also be 20 centimeters. Might be handy to have that showing. It also shows a semicircle, which is in here. The semicircle including A and B, and also an arc of a circle, which is A, C, and B. AB is the diameter of the semicircle. Looks like it is. That'll be the centre there. and AC is an arc of a circle with centre B. So there would be an entire circle that would go all the way around here where the centre would be B. So show that the area of the shaded region divided by the area of the square is equal to pi over 8. So we need to find out the area of the shaded region. Now the area of the shaded region, to me, looks like this quarter circle, which is A and then C and then B. Take away the semicircle, which was A and B. If I had this here and I cut out a chunk that was like that, okay, I wouldn't have this bit, I would have this bit up here. Okay, sometimes it's easier to draw these things out. So, this arc, it is 1/4 of one absolutely gigantic circle. And that circle would have had a radius of 20. This is the centre to the edge, we've got 20. So that's going to be 1/4 of pi times r squared minus 1/2 of, the radius here would be 10. This is the diameter, so the diameter is 20, the radius is 10. Pi times 10 squared. Now that would be 1/4 of 20 times 20, which is 400 pi, minus 1/2 of 10 times 10, which is 100 pi. 1/4 of 400, that's 100 pi, minus 1/2 of 100, which is 50 pi, and we'll be left with 50 pi. And that is the size of that shaded area. And it says, show that the shaded region divided by the area of the square. Now the area of the square is equal to 20 squared, which is 400. It's 20 multiplied by 20. So the area of the shaded region, which was 50 pi, over the area of the square, which is 400, does that equal pi over 8? Well, yeah, it does, because I can divide the numerator by 50 and divide the denominator by 50, and I'll end up with 50 divided by 50 is 1 pi, and 400 divided by 50 is 8. And there we go, we get pi over 8. Not too bad. Let's move on. Write down the exact value of tan 45. Now, there are a few ways to do this. Some people just memorize it. Some people use like some kind of method where they count on their fingers for it. For me, I've never been good at either of those two things, and so I use a magic triangle for it. If I know that this is 45 degrees, I know this is a right angle, I know this is 45 degrees. If I said this was 1 and this was 1, because this is an isosceles triangle, these two things are equal to each other, 1 squared plus 1 squared is 2 rooted would be root 2. So tan of 45, starting at 45, we've got tan of 45 equals the opposite over the adjacent. Toa, toa, toa. So we've got tan of 45, which is equal to the opposite, which is 1, over the adjacent, which is 1. So tan of 45 is equal to 1 over 1, which is 1. So tan of 45 is 1. Here is a right angle triangle. It's got 4 here, it's got x here, it's got 60. Now related to this angle, we're trying to find out x. Related to this angle, we've got an opposite side here. We've got an adjacent side. Remember, your opposite side is going to be opposite the angle. A is for adjacent, A is for angles. It's going to be smack bang in between these two angles, between the right angle and whichever angle you're actually using. Okay, A is for angles, it's going to be between. And H is hypotenuse. Hypotenuse, it's the highest length. It's the one that goes all the way opposite to the right angle. Is one thing, but it's the longest length in the triangle, and that's really important to remember. So what we've got is actually the adjacent and the hypotenuse. Now, we know that when you're working with adjacent and hypotenuse for SOHCAHTOA trig, you've got SOHCAHTOA. We've got this one, adjacent and hypotenuse. And so we've got cos of an angle, it's often called theta, sometimes called x or y, is equal to the adjacent over the hypotenuse. Now in this case, the angle is 60, the adjacent is 4, and the hypotenuse is x. Now cos of 60 is equal to 0.5, so 0.5 is equal to 4 divided by something. What do you have to do out 4 by to end up with a half? Well, clearly it's 8. Another way that you could think of this, sometimes people find these a little bit more tricky than they should. If you imagine you just had 5 equals 10 over x, what do you have to divide 10 by to end up with 5? It's clearly 2, isn't it? but x is equal to 10 over 5. 10 over 5 is 2. You can take these and you can almost swap them. Okay, provided you swap the entire denominator and you swap the entirety of this side, this top bit of this side, you're okay. So I've got x is equal to 4 over 0.5. I can double the numerator and double the denominator and I'll get x is equal to 8 over 1. X equals 8. Okay, x is 8 centimetres. Moving on. Now this question is quite it's quite crammed in on this page, unfortunately, but that's the way cumulative frequency questions tend to be. So the times that 48 trains left a station on Monday were recorded. You can see that it's 48 on the graph because the very top bit of the graph up there, that's across from 48 there, that's 48. The cumulative frequency graph gives the information about the number of minutes the trains were delayed correct to the nearest minute. The shortest delay was 0 minutes and the longest delay was 42 minutes. Okay, fine. So on the grid below, draw a box plot for the information about the delays on Monday. Now, to draw a box plot, you need a lowest value, a lower quartile, a median, an upper quartile, and a highest value. Now, the lowest value was equal to 0. That's given. The lowest delay was 0. The longest delay was 42. Now, if there were 48 trains on Monday, which one's the median? Well, the median would be the 24th train, wouldn't it? So we can go across from 24. Okay, be careful here. There's 25, so it's just one box underneath. And down. Obviously, I should be using a ruler, but I don't have one at the moment on this thing. So my median is 10. Okay, it's halfway into the data. If there are 48 people, then it's halfway into the data. That's what medians have always been. Now, your lower quartile is a quarter of the way into the data. Well, what's a quarter of 48? Oh, that's 12. So it'll be the 12th piece of information, which actually happens to be here. Now, the 12th piece of information goes at 4 for its minutes being delayed. So we'd expect that the 12th slowest train was 4 minutes late. We're not sure whether that's perfectly right, but that's what we've got from our graph. Next, we've got the upper quartile. Now, that is found at 3/4 of 48. Well, if 1/4 of 48 is 12, then that's 3 times 12, which is 36. It's the 36th piece of information. So there's 36. We'll go across. I should be using a ruler. And then down. And we've got 20. Okay. Now, my box plot is going to go with 0, which is my lowest value. My lower quartile is 4. My median is 10. My upper quartile is 20. And my highest value is all the way up here at 42. Now we can draw in our box plot. Now some people draw their line all the way from there to there. That's fine. Doesn't really matter, to be honest, but if the one below doesn't have that line all the way across, then I'll just copy that one. Alright, now what that means is that 25% of the trains were in that bit there. 25% of the trains were in that bit there, 25% of the trains were in that bit there, and 25% of the trains were in that bit there. So the 25% of slowest trains were between 20 and 42 minutes late. So those slowest 12 trains would have been between 20 and 42 minutes late. Next, it says 48 trains also left the station on Tuesday, which is nice. The box plot gives information about the delays on Tuesday. Compare the distribution of the delays. Now, what I'm not looking for is people saying, well, it appears that the trains were better on Tuesday. There were less delays or something like that. It's not about your opinion. Your opinion isn't what we're after in this case. What we're after is an analysis of the median and also an analysis of a spread. It's called a measure of spread, and most often people just use a range. Okay. Now, the median on Monday was 10 versus on Tuesday, which was 9. Median on Monday was higher. It was 10 versus 9. The range on Monday is clearly higher. It's 0 to 42, so it's 42. So range on Monday is higher. and it is 42 versus 33. Okay, that's what you're after when you're comparing distributions. I don't need to hear a big story about what's going on at the train station and people saying that, people must have been slower on Monday for whatever reason. Give me a measure of spread and the median. That's what we're after. Mary says the longest delay on Tuesday was 33 minutes. She's right. She said this means that there must be some delays between 25 minutes and 30 minutes. Now 25 minutes is there and 30 minutes is there. Now if there were 48 trains on the Tuesday, that means there would be 12 in there, 12 in there, 12 in there and 12 in this region here. And what Mary is saying is that because there's one up here, there must be some in there. Well, that's not necessarily right. It could be that all 12 of them were in this bit here. It could be that just that one was there and 11 of them were in that section there. There might not have been any delays between 25 and 30. So is Mary right? Not necessarily. She might be. When you're spelling that, one collar, two sleeves, one C, two S's. Not necessarily. There may have only been delays in the upper quartile between, let's pick something out that doesn't even match against that. We're going to go with 32 minutes, 31 minutes to 33 minutes. Between 31 minutes to 33 minutes. That might just have been the way it is. Okay, there might have been all these 36 here and then nothing delayed, nothing delayed, nothing delayed, nothing delayed, and then a big chunk of delays there. Could be. Okay, but Mary's not necessarily right. Let's move on. Now in this case, we've got x minus 1 over 5 lots of x minus 1 all squared. Now it would be a massive mistake for you to expand all of this out. Bracket this. We have x minus 1 lots of 5 lots of x minus 1 lots of x minus 1. So write it out long by all means, but don't expand it out and give me x squared minus 2x plus 1 or something like that. It's not needed. Now what I can do is I can cancel that off and that off. So we'll get 5 lots of x minus 1 in the denominator. We actually have a 1 here in the numerator. There's one lot of x minus 1 on the top. It's not going to be blank, it's not going to be 0. If it was 0, then the whole thing's 0. Wouldn't make any sense. Now you can leave it like that, or you can expand it and give me 1 over 5x minus 5. Alright, next up, factorise fully. Now as soon as you see something that looks like this, that's got a power of 2 and a not power of 2, and it's got two terms and it's got a subtraction, you should be thinking there's a difference of 2 squareds in here. So we're going to have a look at what we do with it. First, we're going to divide out the 2. 2 is a common factor. 2's into 50 go 25 times. 2's into 2 go once. Y squared is y, and the minus is the minus. So we actually get 2 lots of 25 minus y squared. Now, we're going to factorise this thing. Now, this is called a difference of 2 squares. Of 2 squares. Let's have a look at why it is that it's called that. So is 25 a square? Well, it's a square number, yeah. 5 times 5 is 25. Is y squared a square? Yeah, it is, because y times y is y squared. Is it a difference? Well, a difference is a minus, isn't it? Okay, so we've got the difference between these 2 square values. This is called the difference of 2 squares. And to factorise that is really easy to do. What's the square root of 25? Well, that's 5 and then 5. What's the square root of y squared? It's y and then y. And you use one with a plus and one with a minus. These are called conjugate brackets. If you were to expand it, you do 5 times 5 and get 25, plus 5y, take away 5y, and plus 5y, take away 5y would disappear, and y times negative y would be negative y squared. So you get what you're after there. It's called the difference of 2 squared. All right, moving on. Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here's Jack's idea for the special offer. You put 25% more cereal into the box and don't change the price. Here's Sadia's idea. He said, reduce the price, but don't change the amount of cereal in the box. Sadia wants her idea to give the same value for money as Jack's idea. By what percentage does she need to reduce the price? Now, value for money, in this food sense here is how much cereal do you get? So the amount of cereal divided by the price. Okay. Now, in Jack's case, he says put 25% more cereal into the box. So Jack's saying that we're going to have 125% of the cereal. Okay. Which I'm going to express as 1.25. You should know that 125% is equal to 1.25. So he's got 1.25 lots of the cereal divided by the price. Okay, there's his value for money. Now, Sadia said, reduce the price, but don't change the amount of cereal. So you're still going to have the exact same amount of cereal, but we're going to have something multiplied by the price. We're going to have some value. I'm going to call it K, because we don't know what it is just yet. We're going to have K times the price. Now, what you can see is that these two things have been made equal because we're after the exact same value for money. So in Jack's case, he's increasing the amount of cereal. In Sadia's case, he's keeping the exact same amount of cereal. In Jack's case, he's keeping the same price. In Sadia's case, we're going to have some reduction in the price, and we don't know what it is just yet, but we'll find out. Now, I'm going to write that a little bit nicer, so I'm going to call it 1.25 C over P is equal to C over KP. Now, I'm going to divide both sides by C over P. Okay, I'm going to cancel off the C's and I'm going to cancel off the P's. If you want to take a little bit longer over that, you can. A nice way to do that is to have 1.25 C KP, so multiplying that up there, and then to have equals 1 CP. To multiply that up there, and then we can cancel off the C and the P, and we'll get 1.25 K equals 1. Now that means that K is equal to 1 divided by 1.25. Now what's 1 divided by 1.25? Well, it's tricky to work out, but I want to get it out of decimals if I can. So I'm going to have 2 over 2.5. I'm going to say, well, that's 4 over 5. Which is going to be, 4 over 5 will do. So K is equal to 4/5. So what Sadia is saying is, Sadia wants to sell the cereal for 4/5 of the price. Which is a 1/5 reduction. 1/5 is equal to 20%. So what percentage does she want to reduce the price by? Well, she needs to reduce the price by 20% in order to produce the exact same value for money. It's tricky, it's a tough question, but we should be able to move on. Okay, circle theorems. A, B and C are points on the circumference of a circle with centre O, that's fine. DAE is a tangent, it's a straight line tapping at A, great. Angle BAE is 56 degrees and angle CBO is equal to 35 degrees. Work out the size of angle CAO. Now there are tons of different ways to do this. I'm going to show you a really cool way to do it. We've got C to A to O, which is this thing here that I'm going to call X. Now this here, whenever you've got a line with a triangle, and that triangle has to fit exactly tapping the edges of the circle, that is called an alternate segment theorem, and this here will be the same as this, and this one will be the same as this one. Okay, we have an alternate segment theorem, so this being 56 means that this is also 56. Now look carefully, this question says show you working. This doesn't say give reasons for every step that you take. If it asks you for reasons, you would have to say that BAE is equal to BCA and put in brackets the alternate segment theorem. But it doesn't ask you for that, it's just asking you to show the working. Okay, now here's a pretty cool way of doing this. I'm going to put a radius here It's a really weird way of doing this question, but I thought it was an interesting one, so I think it's well worth showing. So this triangle here, the triangle OBC, O to B to C, this triangle in here is an isosceles triangle because this and this are of equal length. They're both radii. That means that this angle and this angle must be the same. So that is 35 degrees. Now what we're saying is that this is 56 here, and this is 35, then what's this gap here? Well, it'll be 56 take away 35, which is equal to 21 degrees. That there is 21 degrees. But look here, OCA is also an isosceles triangle, meaning that this angle here must be equal to this angle here. So X is therefore equal to 21 degrees. So not the only way to do that question, but I think it's a really cool way to do it. Let's move on. Describe fully the single transformation that maps triangle A onto triangle B. Well, is it a rotation? It looks like it's been rotated, but it certainly doesn't look like it's the right size. Is it reflection? No, because the size shouldn't change. Is it translation? No, the size shouldn't change. This is clearly an enlargement. Now, because the orientation has changed, because things look like they've been sort of rotated as well as the size being changed, it's going to be with a scale factor that's negative. Minus something. If it was positive something, the orientation would be the same, but the size might change. And so you might have, say, like another triangle that looks a bit like that, you know, the same sort of direction. Whereas in this case, it's not the same sort of direction. Now, this line here, for me, matches this line here. Now, this was 6, whereas this is 2. So it is now 1/3 of the length. So the scale factor is negative 1/3. We also need to find the centre of enlargement. You can't just describe some of it, it says describe fully. Now the centre of enlargement, a really nice way to find that is to match up corresponding corners. Okay, and we're going to match up this corresponding corner with this one. There. Okay, and when you get those corresponding corners matched up, wherever they cross, that's the centre of enlargement. So the centre of enlargement is 2, 2. The same goes for if you've got, say, like one shape like that and then another shape like this. Well, the centre of enlargement would be there. Okay, it doesn't matter whether you've got a positive or negative scale factor, it's just match up the corners and carry on your lines, and there you go, that's done. Moving on. Work out the value of 16 over 81 all raised to the power of 3/4. So now we're getting up to the really heavy difficulty stuff. Now, this here, it's important to understand how these things can be dealt with. Now, here's a tree. The roots of the tree are at the bottom. The root in this power fraction is at the bottom. This means that we have the 4th root. This here is the power. So what we actually have is the 4th root of 16 all raised to the power of 3. Always, always, always do the root first. Otherwise, you'll be trying to do 16 cubed, which is massive, and then trying to 4th root it. It'll take you absolutely ages. I certainly wouldn't want to do it. And then we've got the 4th root of 81, all raised to the power of 3. So use the root first and then use the power. Now the 4th root of 16, what number multiplied by itself, by itself, by itself, by itself, to get 16? Well, 1 times 1 times 1 times 1, no, that's 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, so that would be 2 cubed. 3 times 3 is 9, times 3 is 27, times 3 is 81, so this would be 3 cubed. The 4th root of 16 is 2, the 4th root of 81 is 3. 2 cubed is 8, 3 cubed is 27. There you go, 8 over 27. Alright, moving on. 3 to the power of A equals 1 over 9. 3 to the power of B equals 9 root 3. And 3 to the power of C equals root 3. Now there are things that you need to know to start with. Okay. First off, 3 squared is equal to 9. That's handy. 3 to the power of 1 is equal to 3. That might be handy. It doesn't actually work out to be. 3 to the power of a half is equal to the square root of 3. We should know that. Look, see where the roots are? The root there? That's a square root. Square root. The roots are found at the bottom of the tree. So this is a square root of 3. You could, if you want, put the little 2 there, but nobody does. 1 over 9, okay, so we've got 3 to the power of a is equal to 1 over 3 squared. Now this is upside down, isn't it? It's 3 squared, but it's upside down. And so we've got 3 to the power of negative 2 equals 3a. If you've got things being flipped, it means that your sign is negative on the power. And so we know there that a is equal to negative 2. Next, we've got 3 to the power of b is equal to 9 root 3. Well, 9 is 3 squared times by 3 to the power of a half, which is going to be 3 to the power of 2.5. So therefore, b is equal to 2.5. And then we've got 3 to the power of c is equal to 1 over root 3. Now that is going to be 3 to the power of a half, but look, it's been flipped again, so that's a negative a half. So c is equal to negative 1/2. Okay. Now to add those up, we've got a plus b plus c. We've got negative 2 plus 2.5, take away a half, which is take away 0.5, isn't it? Minus 2 plus 2.5 is 0.5. 0.5 take away 0.5 is 0. Okay, so a plus b plus c is 0. All right, next it's question 15. 3 solid shapes A, B and C are similar. Now the surface area of A is 4 centimeters squared and the surface area of B is 25 centimeters squared. Looks a bit like we could use it for some sort of scale factor ratio, but we can't just yet. The ratio of the volume of shape B to volume of shape C is 27 to 64. Now that is useful. Work out the ratio of the height. Now the height is a linear dimension of shape A to the height of shape C, which is obviously also linear. Now, if we look at A and B, we know that we've got linear area and volume are going to be related to each other. Now the area is the centimetres squared, the volume is the centimetres cubed, and the linear is the centimetres. So if we said that the surface area is 4 to 25, we can square root that to get the linear scale factor. Okay, we can square root it. If you look at it, we've got centimetres squared, get back to centimetres, we can square root and we can get 2 to 5. Okay, centimetres squared. So you've got the normal one, we can square it to get centimetres squared. We could cube this to get the volume as well, which is 8 to 125. It turns out that we don't need that, but it's nice to have these. Okay, your linear squared makes your area, your linear cubed makes your volume cube rooted makes you linear. Okay, we're going from a power of 3 down to a power of 1. All right, now that's what we've got so far, but for B and C, we've got B to C, we've got linear, area and volume. Now the volume is 27 to 64. Now to get to the linear, we're going to cube root that. Okay, we're going from cubed down to a power of 1, so we're going to cube root it, which is going to be 3 to 4. We could also, if we want, square that to get the area scale factor to be 9 to 16. Doesn't actually come out to be useful, but there we go, just for completion. Now, work out the ratio of the height of shape A to the height of shape C. Now that's the linear section. Now, A to B in the linears was 2 to 5. But B to C was 3 to 4. I need some way to get these to all be on the same row. Now, if the height of B was 15, then the height of A would be 6. I should say times by 3 there. If the height of B was 15, the height of A would be 6. Because we're going to multiply this by 3, multiply this by 3. If the height of B was 15, by multiplying by 5, then the height of C would be 20. So if the height of A was 6 and the height of B was 15, well, given that the height of B is 15, the height of C must be 20. So actually, A to C are in the ratio 6 to 20. That's not simplest form. Don't do all this work and then accidentally miss off a pretty basic thing. Divide both sides by 2 and you'll get 3 to 10. Okay, moving on. Nice for this to come up as question 16 because it's not difficult. So we've got prove algebraically that 0.2565656656 can be written as that fraction. So the first thing to do is to write out quite a bit of that number. 0.25656656 ... is equal to x. Okay, we don't know what x is just yet, but we're going to try to find out what x is. We do know that x has exactly this value here. And so hopefully we'll find out that x has also got exactly this value here, which means that those two things will be the same. Now, how many numbers are repeating? Well, the amount of numbers that are repeating is 2. So we're going to multiply by 10 to the power of 2, 10 squared. If there's 3 numbers repeating, we'll multiply by 10 cubed, which is 1,000. If there's 1 number repeating, we'll multiply by 10 to the power of 1, which is 10. We're going to multiply by 10 squared. Now that will be multiplied by 100. When we multiply by 100, we'll get 25.656565 blah blah blah. So it'll be 25.65656656 ... equals 100x. Okay, that's taking this value and multiplying it by 100. Now, what we're going to do is we're going to do a subtraction. 6 take away 6 is 0. 5 take away 5 is 0. 6 take away 6 is 0. 5 take away 5 is 0. 6 take away 6 is 0. And 5 take away 5 is 0. Everything to the right of that little dotted line there, they'll all just disappear. They'll all match forever and ever and ever. So we'll actually get 25.4 is going to equal, well, 100x take away 1x. If we've got 100 x's and we take away 1x, we're going to be left with 99 x's. A really common error is to just cancel off the x's and just put 100 there. It's totally wrong. Now 25.4 is equal to 99x, which means that 25.4 divided by 99 is equal to x. Now I'm going to multiply the numerator by 10, and I'm going to multiply the denominator by 10, and I'm going to get that x is equal to 254 over 990, because I really don't like having a decimal within this fraction. Now we can cancel it. Look, they're both even, so we're going to divide them both by 2. And we're going to end up with 127 over 495. X equals 127 over 495. Job done. All right, moving on. Question 17. The equation of this curve is y equals x squared plus ax plus b, where a and b are integers. So this is a quadratic. The points 0, -5. Now 0 across -5 will be down there. And 5, 0, or 5 across and up 0 will be there. Lie on the curve. Find the coordinates of the turning point of the curve, so we want to know that there. Now, this curve here has to look like y equals x squared plus ax minus 5. Okay, this here will always be the crossing point on the y-axis. Whether there's a number in front of x squared or not, it'll always be this thing that does it. So it'll be take away 5. But not only that, y also has to be able to fit into 2 brackets. Now, this bracket here would have been x minus 5. Okay? Because to find the solutions, you solve the bracket, you would have had x minus 5 equals 0, x equals 5. And then we've got this value here that we don't know just yet. We have no idea. So I'm going to call it x plus w. Don't know what it is just yet. Now, if I was to expand this out, I'd get x squared minus 5x plus wx minus 5w. And that must equal exactly the same as that. These two things must be equal to each other, which means that w would equal to 1, because -5 times by 1 must make -5. So w equals 1. So the actual equation we've got is x minus 5 lots of x plus 1. So that there is -1. Okay? Now, there are 2 ways to go about this solve here. We could use the line of symmetry method, which is really nice, Halfway between these would be 2, and we can substitute 2 into this equation, and you'll end up with y is equal to negative 3 times by 3, which is negative 9. And so you end up with your coordinates of your turning point being 2 and negative 9. All quadratics will be symmetrical over their line of symmetry, over their turning point. Okay, the turning point will always fall over a line of symmetry. And there's a gap of 3 here and a gap of 3 here. That's why I chose 2. That's one way to do it. Another nice way to do it is to use completing the square. Now, if we know that y is equal to x minus 5, x plus 1, that will be y is equal to x squared minus 5x plus 1x, x squared minus 4x minus 5. You might take a little bit longer over that. Complete the square, x minus 2 all squared minus 4 minus 5. Okay, remember you halve this, so split and square and subtract. Okay. You need to square the 2 to get the 4 and always make a subtraction happen, and so you end up with x minus 2 all squared minus 9. From here you get the opposite of this sign. If it was a minus, we're going to end up with 2, and here you get negative 9. There's your turning point. There's 2 ways to do it, nice ways to do it, they're pretty easy. Okay, moving on. Question 18. The graph of y equals f of x is shown on the grid below. It looks a bit like a quadratic, but we don't know which one it is. Okay. On the grid above, sketch the graph of y equals f of x minus 2. Now, if we are inside the bracket, then we're affecting x. It also tells lies. Inside the bracket, it affects your x, but it tells lies. It says that your x's are going to get smaller by 2. Actually, my x will get bigger by 2. If we had, for instance, this, that would affect y, and it would tell the truth. Your y's look like they're going to get smaller by 2. They do get smaller by 2. X is going to get bigger by 2. Now, what I like to do is to put on some little dots or put on some little crosses of points that hit grid lines. Now, at the moment, my x is negative 1 here. Well, bigger than that by 2 would be 1. At the moment, my x is 0 here. Bigger than that by 2 would be 2. At the moment, my x is 1 here. Bigger than that, 3. Similarly, here, from 2 goes up to 4 and from 3 goes up to 5. Actually, the curve will look something, hopefully a little bit better drawn than that. But there you go. Okay, make sure you put those little crosses on the grid lines, because those are what's most important about the marking. Moving on. On the grid, graph A has been reflected to give graph B. It's actually been reflected over the y-axis. The equation of graph A is y equals g of x. Write down the equation of graph B. Now, have the y's changed? So the y-intercept, no, that's not changed. Has this bit changed? No, not really. So vertically, they're exactly the same. It's actually the x is changing signs. Okay, it's going from negative 3 point a bit up to positive 3 point a bit. Okay, the x is changing the sign, so we know we're inside the brackets. That means that we've got b is equal to y equals g of, well, x changing signs is going to be there, x changing signs. That's the only time that the bracket ever tells the truth when you're dealing with a transformation on x. So we've got, for equation of graph B, y equals g of negative x. Alright, next up, question 19. F of x equals x plus 1 all squared and g of x equals 2 lots of x minus 1. Show that g of f equals that mad looking stuff. Now, this is g with an f in it. So, rewrite g of x as 2 and leave a gap here, because there's our g of x, and we're going to plug in the f into there. Okay, g with an f into it. So then we'll get g of f of x, which is going to be x plus 1 squared. We're going to swap this for all of this. That's what happens when you're doing these compound functions, composite functions. Now, that will be 2 lots of, well, we've got x plus 1 all squared. Well, x plus 1 all squared is going to be x lots of x plus 1 plus 1 lots of x plus 1. It won't be x squared plus 1 squared. It's got to be these other bits in the middle. Whenever you square in a bracket, multiply the bracket by itself, okay? You should be thinking of this, okay, which is why I've got this bit here. X times x is x squared plus x plus 1 times 1 is 1. So you'll get x squared plus 2x plus 1 with a minus 1 on the end, which will equal 2 lots of x squared plus 2x. It looks almost like this, but we need to factor out an x. We'll factor out an x from each of these, so we'll get 2 lots of, we'll divide this by x, is going to be x. Divide this by x, it's just going to be 2 left over, and you get what we were asked for. Find g to the negative 1 of 7. Okay, there are a few ways to go about this. There are a couple of ways to go about it. You can do it really, really easily, to be fair, and you can do it using actual inverse functions. Now, using the inverse functions is a little bit tricky, really. Okay, now looking at g of x, okay, we put in a number, we apply g of x to it, and we get an output. Okay, that's what happens. We put in a value of x into here, we apply g of x to it, and we get an output. With g of negative 1, we would do this stuff, but in the other order. So we would have the output going into g of x and giving me my input. I can actually, if I want to, mess around with this stuff here. It's a bit fancy. People don't tend to like doing it. So I'll show you the way to deal with it just as a nice way to do it using rearrangement here. So if we've got g of x, which is equal to 2 lots of x minus 1, that will mean that g of x is equal to 2x minus 2. Now we need to change the subject of this formula to make x the subject. Now this thing, to rearrange this formula, we're going to try to develop a form. So I'm going to ignore g of x and I'm going to make it into y. And I'm going to make x the subject. So y plus 2 equals 2x. Y plus 2 all over 2 equals x. And this will give me my form. This here will be the g to the negative 1 of x. And this here will be where x goes. Okay? Now, when x is 7, g to the negative 1 of 7 is equal to 7 plus 2 all over 2, which is equal to 4.5, because 9 over 2 is 4.5. Okay? It's a little bit tricky, really. The other way to do it was similar to what I was mentioning here, which was to just solve that equation, but it's really difficult to come up with how that sort of works based on all of this information here. Sometimes people find that really difficult. Okay, you get 3.5 and add 1 on, you get 4.5. It looks like it should be easier, but it's very difficult to spot how that's going to happen. Okay, moving on. Question 20 looks terrifying, but it's actually really easy, this one. It says show that root 18 plus root 2 all squared all over root 8 minus 2 can be written in a particular form. Now, we're going to tidy up what we can first. Root 18 is equal to root of 9 times 2, which is 3 root 2. Now, root 8 is equal to, what's the square factor for 8? Well, it's 4. Square root of 4 is 2, and root 2 is just root 2. So what we're going to end up with is actually going to be 3 root 2 plus root 2, all squared, over 2 root 2 minus 2. Well, what's 3 root 2 plus root 2? Surely that's going to be 4 root 2's over 2 root 2 minus 2. Now I'm going to divide the numerator by 2 and divide the denominator by 2, because 2 is actually a common factor for every single one of these terms. So I'm going to get 2 root 2 over root 2 minus 1. Remember, you You don't divide these surds by this number here. You're going to be dividing the coefficients of the surds, or just the numbers. Now that's not quite in this form, so actually what we're going to need to do is to rationalise the denominator. Now this is difficult, rationalising the denominator. We're going to multiply by the conjugate of the denominator. Okay, so we'll get root 2 plus 1, root 2 plus 1. 2 root 2 times by root 2. Well, 2 times root 2 times root 2 is going to be 2 lots of, what do these make? 2. So it's 4 plus 2 root 2 over. We've got this, which is going to be root 2 lots of root 2 plus 1 minus 1 lots of root 2 plus 1. That'll be 2 plus root 2 minus root 2 minus 1. 1 times 1 is 1. Those two things cancel out and we end up with just 1. We don't need that denominator if it's just a 1, so you get 4 plus 2 root 2. It wants it in this particular form. It'd be so annoying to get to this point here and then lose the final mark. Factorise it, and you get 2 lots of 2 plus root 2. And there you go. Okay. Next is question 21. Now this is the second to last question of this paper, and in my opinion this is the most difficult question I've ever seen at GCSE. Don't be afraid if you're watching this and you haven't done lots and lots of vectors before, don't be afraid of this, thinking, gosh, this must be the most difficult topic in the world. Vectors generally isn't as difficult as this question will be. This is a really, really, really genuinely tough question. So we'll try it out, we'll give it a crack. OAB is a triangle, fine. OPM, which is this line here, O to P to M, and APN are straight lines. Well, fair enough, they look like that, don't they? That's done, that's done. M is the midpoint of AB. So if we're going from A to B, M would be the midpoint, it'd be halfway along. Okay, and this would also be a halfway along. Okay. O to A is the vector A. In that direction is the vector A. If I've travelled that direction anywhere else, that would also be the vector A. If we're going opposite to it, we get a negative A. O to B, all this way from O to B here, is the vector B. Fine, got that, done that, done that. O to P to M is 3 to 2. Now if we've got 3 to 2, we've got 3 chunks to 2 chunks. Well, 3 chunks to 2 chunks. This would be 3 of 5 chunks, and this would be 2 of 5 chunks. So this here will be 3/5 of, and this will be 2/5 of. Okay? 3/5 plus 2/5 will be 5/5, which is the entire thing. Okay? So this is 3/5 of the line, and this is 2/5 of the line. Now we're going to be working out the ratio of O to N to B. Now in actual fact, what I'm going to do is I'm going to find out what proportion of O to B, what proportion of this entire line is taken up here. Because if I find that, I'll find out what proportion is here, and then I can get it into a ratio pretty easily. What I'm going to say is that O to N is going to be some chunk of B. Now, I don't know what that chunk is going to be called, but I'm going to call it K of B. It's some chunk. Okay, K might be a half, and so if K was a half, then this would be a half B, and this would be a half B. K might be a quarter. If that was a quarter, then this would be 3/4. Fine, I can get those to be ratios. K can't be greater than 1 if it was, say it was like 2B. Wouldn't be right if that was 2B and that was B. That wouldn't make sense. So I'm expecting K to be less than 1, but it's some scalar on B. It's going in the exact same direction, fine, but it's just some sort of shortening down version of B. So we're going to work out the ratio from O to N to B, and the way that I'm going to do it is I'm going to work with O to N mainly. Now, O to N directly is equal to K of B. Okay? We're also going to try to figure out some other way to get from O to N. Okay? My other way to get from O to N is going to involve me going from O to P and then from P to N. What you want to do really often with these really complicated geometric vector proofs is try to find two ways to make the exact same journey. So O to P first, we need to try to find that out, and then we're going to try to find P to N. So O to N via P. This is the same journey, but going in a different route. So O to P plus P to N. That's the journey that I'm going to be taking. Now O to P is 3/5 of O to M, isn't it? It's 3/5 of that line. Plus, well, we'll deal with the P to N later. We'll come to that in a bit. We want to tidy up this as best we possibly can, and then we'll deal with the P to N in a minute. Now 3/5 of O to M. So what's O to M? Well, O to M is A plus 1/2 of the vector from A to B, isn't it? It's A plus 1/2 of the vector from A to B, which is A plus 1/2 of, well, to get from A to B, you've got negative A going against the grain here, so that'll be negative A plus B. So O to M must equal A, take away half an A, which will be a half an A, plus a half of B, which is 1/2 of A plus B. So to get from O to M, which is this entire line here, that's 1/2 of A plus B. Now what we said was that O to P was equal to 3/5 of that line. So we can expand in these fractions and we end up with 3/10 of A plus B. That's from O to P, which was 3/5 of O to M. O to M was this chunk, 3/5 of 1/2 of A plus B was this bit. Now P to N, it lies on the line A to N. We don't know how much of that line it actually takes up, but we're going to say, well, P to N is actually equal to some chunk, some ratio. I'm going to call it R because I haven't used that letter yet. R of A to N. Now that's going to be R of, well, to get from A to N, how do you do it? You go negative A plus KB. Negative A plus KB. Now what I'm going to do here is I'm going to expand this out. So I'm going to end up with R lots of negative A, which is going to be negative RA, and R lots of positive KB, which is going to be plus RK of B. I'm also going to expand out this bit over here on the left, which is going to be 3/10 A plus 3/10 B minus RA plus RK of B. Now that is another way to get from O to N. That one's via P. It's as tidy as it can get, really. It's still a mess, but it's as tidy as it can get. Now this journey here, going direct, gives me the exact same vector as going on this journey here. So what I can do is say that those two journeys must be equal to each other. KB is going to equal 3/10 A plus 3/10 B minus R of A plus R of K of B. Now look here, on this side, how many A's do I have? I've got 0 A's. There's none of them. So what I know is that this term here and this term here, because they're the only ones with A's in, must add up to make 0. 0A must equal 3/10 A minus R of A. So that tells me that R is equal to 3/10. Okay, 3/10 take away 3/10 would be 0. So R is equal to 3/10. Now let's compare the B's. We've got K of B must equal 3/10 of B plus R, which is 3/10 of K of B. Okay, now I'm going to divide everything by b. And I'll end up with k equals 3/10 plus 3/10 k. Okay, so k, quite close towards the end, so I can choose this box here. K equals 3/10 plus 3/10 k. I'm going to multiply everything by 10. 10 equals 3 plus 3k. 10k, pardon me, equals 3 plus 3k. Now I'm going to take 3k off both sides, and I'll end up with 7k equals 3. And divide through by 7, k equals 3/7. Now what that means is that O to n is actually 3/7 of this line. Okay, this will be 3/7 here. So therefore n to b would be 4/7 of this line. So O to n is 3/7 of b, and n to b is going to equal 4/7 of b. Now what I wanted was the ratio of O to n to b. So I can cancel off the b's and I can cancel off the 7's, and I'm left with 3 to 4, and that's done. Okay, in my opinion, that's probably the most difficult GCSE question I've ever seen. It's a really, really, really tough one. It wouldn't be out of place in the first year of A-level, certainly. Okay, and it'd be difficult on that, really, to be fair. So, tough one, but let's move on to the very last question of this paper, which is weirdly easier. So, there are only green pens and blue pens in a box. Fine. There are 3 more blue pens than there are green pens in the box. Fine. There are more than 12 pens in the box. Okay. Simon is going to take at random 2 pens from the box. Now he's taken those 2 pens at the exact same time, which means that we've got non-replacement. If you're thinking about this in terms of tree diagrams, you've got non-replacement, which means that your probabilities are going to change when you pick the first pen versus when you pick the second one. The probability that Simon will take 2 pens of the same colour is 27 over 55. Now what that means is that the probability for Simon taking a green and then a green plus the probability of Simon taking a blue and a blue will equal 27 over 55. So what I'm going to need to do is try to get some expressions for these. Work out the number of green pens in the box. Now there are 3 more blue pens than there are green. So how many greens are there? Well, there's G greens. We don't know what they are. How many blues would there be? If the G greens, well then it'd be G plus 3 blues. And in total there'll be 2G plus 3 pens overall. Okay, the total amount of pens is 2G plus 3. Now, Simon is going to take 2 random pens, so we're going to get the probability of getting green and then green first. So on his first go at picking out a green pen, there are G green pens, out of a total of 2G plus 3 pens overall. Now when we take our first pen, those are the probabilities, but for taking our second pen, we're going to take 1 off each of these probabilities. Okay, there'll be 1 fewer green pen, so we'll have G minus 1, and there'll be 1 fewer pen overall. Instead of having 2G plus 3 pens in the box, there'll be 2G plus 2 pens in the box. We'll expand that and we'll get G squared plus G over, well, I don't really know straight off the top of my head what 2G plus 3 lots of 2G plus 2 is. So I'm just going to work that out here. I've got 2G lots of 2G plus 2 plus 3 lots of 2G plus 2. It's okay to do some working out by the side of your page. It's fine. Don't try and get it all in within every single line. You'll be ages doing it and it'll only be more confusing. So you get 4G squared plus 10G plus 6. That's the probability of getting a green and then a green. The probability of getting a blue and then a blue, well, that will be, to start off, there are G plus 3 blues over 2G plus 3 pens overall. Now on my next go, there'd be 1 fewer blue, so actually there'd be only G plus 2 blues over 2G plus 2 pens overall. Oops, I've made a mistake here. You see here, when I expanded here, I should have put a minus there. Okay, there's an error in there. Watch out for that. Okay, it's a silly error. So when I expand this out, I'm going to get G plus 3 lots of G plus 2. g lots of g plus 2 plus 3 lots of g plus 2. You might be a person that uses FOIL, it's fine. 2g plus 3g plus 6. So that will be g squared plus 5g plus 6 over, the denominator is going to be exactly the same, 4g squared plus 10g plus 6. Alright, so the probability it's going to take two pens of the exact same colour will be these two probabilities added together. It's got to equal 27 over 55. But look, the denominators are the same. Okay, if I add 1 7 plus 2 7s, I get 3 7s. I don't change the denominator when I add some stuff up. So what I'm going to have is the probability of getting the exact same colour twice is going to be g squared plus 5g plus 6 plus g squared minus g. Okay, that's this numerator plus this numerator, all over 4g squared plus 10g plus 6 is equal to 27 over 55. I'm going to collect the like terms in this numerator here, so I'll get 2g squared plus 4g, because that's 5g's take away g, which is 4g plus 6, over 4g squared plus 10g plus 6 equals 27 over 55. Alright, now look here, you see this numerator here, I can divide this by 2. So long as I divide the denominator by 2. Everything in there, all of these terms are all even. So I'm going to do that just to make things a little bit easier. If you're in question 22 of a paper, you should be looking for anything that can make things easier, and you should certainly be able to understand what I've just done. So we're going to divide all of these by 2. So we'll get g squared plus 2g plus 3 over 2g squared plus 5g plus 3, which is equal to 27 over 55. Now, we can cross multiply here. I can multiply this denominator by 27 and multiply this denominator by g squared plus 2g plus 3. Okay, we should know, for example, that 2 over 8 equals 1 over 4, because 2 times 4 is equal to 1 times 8. Okay, these two things multiplied together equal these two things multiplied together. Okay, so we get 55 lots of g squared plus 2g plus 3 is equal to 27 lots of 2g squared plus 5g plus 3. 55g squared plus 110 g plus 165 is going to equal 54 g squared plus, well, 27 times 10 is 270, halved is 135 g plus 81. Now I'm going to get this all onto one side. Now look for which side has got your higher value as a coefficient to g squared. I've got 55g squared and I've got 54g squared. So I'm actually going to move this stuff all over to the left hand side in order to keep the coefficient to g squared positive. So let's take off 54g squareds. I'll end up with g squared. Because 55g squared, take away 54g squared is 1g squared left. I've got 110g's take away 135g's. Well, that'll be take away 25g. And I've got 165 take away 81, which is going to be 84. All right. Now, this thing here, we can actually factorize this. Okay, the factorize for this is really nice. It's two numbers that multiply to 84, but also add to negative 25. You need two numbers that will do that. And those numbers are negative 21 and negative 4. Negative 21 and negative 4. So you're going to get g minus 21 and g minus 4 equals 0. So there are either 21 greens or 4 greens. We don't know just yet. There are either 21 or 4 greens. Now, we said that there were either 21 greens or 4. If there are 21 greens or 4 greens, then there would be 3 more blues, so that's 24 blues or 7 blues, which means in total there would be 45 blues or 45 pens overall, or 11 pens overall. Now look back to the question. It says there are more than 12 pens in the box, which means that this column here doesn't work. There's too few. So it says that this column here is the one that we want. Work out the number of green pens in the box. The number of green pens in the box is 21. There are 21 green pens in the box. And that is 80 marks on this GCSE paper. You should pause this video, re-watch it, try doing the paper, give it a good old crack. I'll put these slides with all the annotations attached with a link, and I'll just put it in the description of the video. Try to search the paper, you'll find it somewhere. Try it out and come back to this video to see whether you've got things right or wrong. Hopefully this helps. Thanks very much.